Welcome. Greetings from Eastern Iowa Community College. I am Jeff Rose, the Principal Investigator for the National Science Foundation Advanced Technology Education Funded 3D Impact, grant number 1600143. Today we will be reviewing the various types of methods of advanced manufacturing, more commonly known as 3D printing. These slides were prepared by Eastern Iowa Community College faculty members Megan Edens, Susan Lammers, and Brad McConnell. Be sure to visit the links and videos throughout the presentation for a more thorough understanding of the methods presented today. Additive manufacturing uses 3D model data from a designer or a 3D scanner to deposit material, usually layer upon layer, in precise geometric shapes to build an object. This is opposed to traditional subtractive manufacturing that starts with a solid block and the material is removed, usually by a cutting tool. Key differences is that additive manufacturing typically generates less wasted materials and can be less expensive for small quantities of parts, but it is limited in materials that parts can be made of. While traditional subtractive manufacturing is more commonly understood and accepted method of manufacturing, especially when many parts are needed. By far, the most common materials to be used in additive manufacturing is plastics, although metals, food, cement, and biomaterials can also be used. We will only be covering the use of plastics in this lecture. A quick overview on plastics. Plastics are made up of long-chain polymers. A polymer is many poly of monomers, which is a chain of bonded molecules. This is how we get the name polymer. All plastics are polymers, but not all polymers are plastic. For instance, traditional rubber, lubricants, paints, and adhesives are polymers, but not plastics. At the core, plastics can be put into two categories: thermosets and thermoplastics. Thermosets are polymers that are irreversibly hardened. In other words, they cannot be remelted. They are made through a reaction that is started by heat, UV light, and/or mixing with a catalyst. Common thermoset plastics are epoxy and polyester resins, phenylformaldehyde, commonly known as bakelite, and silicone. Thermoplastics are polymers that can be remelted and reformed. They become pliable at elevated temperatures. They are commonly formed using injection molding, compression molding, and extrusion. Common thermoplastic plastics are high-density polyethylene, used as milk jugs, polyvinyl chloride, used commonly as PVC pipe, polypropylene, used for food-safe containers, acrylonitrile butadiene styrene, ABS, and polylactic acid, PLA, which is made up with renewable resources such as cornstarch. The most common plastics used in additive manufacturing is ABS and PLA. Now for a brief history of additive manufacturing. During the 1980s, additive manufacturing began. The first 3D models using thermoset plastics were made, along with the first patents received for additive manufacturing, which were for fused deposition modeling, FDM. The now standardized stereolithography file format was also developed, commonly known as the STL format. During the 1990s, more methods of additive manufacturing were developed, including selective laser sintering, SLS, and binder jetting. The use of additive manufacturing was starting to be used in manufacturing. During the 2000s, fused deposition modeling patents expired, allowing rapid development of this technology. It is now commonly known as fused filament fabrication, FFF, and is the most commonly used additive manufacturing process used today. There are 7 common methods of additive manufacturing technologies. 1. VAT Photopolymerisation. 2. Material jetting. 3. Binder jetting. 4. Material extrusion. 5. Powder bed fusion. 6. Sheet lamination. And 7. Direct energy deposition. VAT photopolymerization is a process that starts with a container of monomers, and using UV light in selected areas, the monomer is polymerized. The stage is then repositioned for the next layer to be processed. This process is repeated many times until the model is complete. Material jetting creates objects by spraying material on a base plate and then building an object layer by layer. Binder jetting deposits binding adhesive agent onto a thin layer of powdered base material. As each layer is built, a new layer of powdered material is laid down and the binding agent is deposited only where desired. Material extrusion is the most common method of additive manufacturing. It is also known as fused filament fabrication. A part is made by extruding a thin line of thermoplastic layer by layer until an object is made. This is similar to putting a bead from a hot glue gun down on a material, waiting for it to cure, then building another layer on top of the first. Repeating this many times will create a three-dimensional object. Powder bed fusion is similar to binder jetting, but uses energy deposition, such as a laser, to heat the material to a sintering point, to bond the powders together where desired. Another layer of powdered material is then deposited and the sintering is repeated until the object is formed. Sheet lamination is a process of laying down a sheet of material, cutting out the desired shape, adhering another layer of sheet material to the first, and repeating this process as the object is built. Direct energy deposition is typically used for building objects out of metal. A wire is fed through a nozzle, similar to welding in a computer-controlled fashion, building up a bead one layer at a time. Another process uses a laser to make a melted pool of metal in which powdered metal is sprayed into. This builds a layer of material, repeating this process layer after layer to build the desired object. Additive manufacturing can be used in many areas. This project encompasses 5 content areas: CNC machining, engineering technology, mechanical design, supply chain and logistics, and welding. In our remaining modules, we will be exploring how additive manufacturing can be applied to each content area. Thank you for your time. Stay tuned.